For this lab, we have the following components. We have an analog discovery 2 from Digilent. We're also going to be using their Waveform software, and that's to look at all of our waves and that come from here. And we're going to be using this pinout right here. It's also on the box that it comes with, which I will be looking at. We have this kit with many different values, but I'm also going to be using another kit from Amazon that has a bunch of little values and jumper wires that are going to be handy and useful. So that's where these resistors come from, because this kit has many resistors, but I like the Amazon one because they come in this little labeled packet. But just to double check, we will also be testing each resistor with our multimeter. We are going to be doing calculations to make sure that everything is set. We have one right here that I'm going to tear down and rebuild just for example for the first one. And then we also have a rubric that we are going to follow. So we have all this material, we have all this equipment, and we have our breadboard, of course. We have these resistors. We are using a OP27G op amp, and it's a pretty good one. We also have more jumper wires and all the equipment that we could need to do this lab. We're going to be working with the capacitor as well later, and that's it for the physical side. Running the Waveform software. I'm running it right now, but I'm going to turn it off, stopping all of this. And to get it to look like this, we would first open up our WaveGen software, so our Waveform software. It says no device detected, but that's already because I have one plugged in. It should read our device. Even if we don't have a device though, we can still do this. We just have to select a simulator. We will be limited in what we can do, and it won't be as lively. But we're going to follow along since we have a device here. We would see if it doesn't detect a device because I already have it connected, we would do Discovery 2 because we're working with the analog Discovery 2, and we select it and then we go into it. To get it to look like this, what we would want to do inside of our welcome page is we want to go into WaveGen. And so our WaveGen is going to be this WaveGen 1 and this WaveGen 2. To get both channels to display, we want to hover and click channels and have channel 1 and channel 2 selected. Now, per the instructions of our lab, which we're going to go over in a second, our frequency needs to be 1 kilohertz, our period in 1 milliseconds, our amplitude should be, for the starting, it should just be 500 millivolts. This might change later in the lab if it's specified. And then we have our offset, symmetry, and then it's a sine wave, and this is the same thing for our channel 2. We are not always going to be running channel 1 and channel 2 at the same time, but that is just good to note. Then from here, we're going to want to go to supplies. Supplies is going to bring up a window just like this, and what we want to have is our voltage set to 5 volts, and our voltage here set to negative 5 volts. And that is putting from the computer to the analog Discovery 2 5 volts that will be given to our breadboard, which then gives it to our op amp, because we need to power our op amp. So our operational amplifier will have 5 volts going through it. And make sure this is off, always off when we're building our circuit. That way we don't short anything out, or we don't have any power running anywhere we don't want it to. So this is always going to be off until we are ready to run our waveform and look at it. We have these measurements off to the side, and we'll get to that in a second, because first we need to look at the scope. So back on the welcome page, we just click scope, and something like this should open up. Now, if it opens up in different tabs, that's okay too. I just have it open all in one big thing because I have ultra wide monitor, and I'm able to see everything here. For our time, we want our position to be at 200 or 250. 200 is also fine. That's kind of just like the position of it. No big deal. We have our base. We want an average of 50. I believe it starts out at 0, but if you have 0, these numbers right here are going to fluctuate a lot. But the average right here, it's taking the average of 50 waves and it's putting it right here. So our numbers will not be as volatile. Whether it is if we have just 1 or 0, that means it's taking the average of every single wave. And that is going to lead to some volatile numbers, but it's much easier to take it at 50. We have this off. This is default, and our sampling rate is going to be 1.587 megahertz for this. our channel 1 is 0 volts, and our range is 1 volt per division, and the same thing for our channel 2. And that is it for the setup of our waveforms. Now we are going to look at our lab. So in our lab, we have the following instructions. It's a lab overview. We have pre-lab, which is just calculations that we have not done yet. And all operational amplifiers require DC power to operate. So the first step in building any op-amp circuit is to connect the DC power supplies. Breadboards have rows of pins at both the top and bottom. It's intended for use as the power supplies, which are typically labeled plus and minus, and also color-coded red for the positive supply and blue for the negative supply. On most breadboards, these rows are connected all the way across. Some breadboards have a break in the middle. Ours does not, so it is connected all the way across. This means that DC power can be connected anywhere in the row, although it is good practice to connect the power supplies as close as possible to our circuit, which is going to be using the power, and this helps to minimize the effects of parasitic resistance, inductance, and capacitance. And that's basically any kind of current leakage, and because we want all of our current flowing to the circuit. The breadboard bypass capacitors are usually added between each power supplies and ground to reduce noise on the supply, but we are not going to be using bypass capacitors here. And this is just the setup that we have here. So we're first going to be starting off with the op-amp's unity gain buffer. And this is very simple. The op-amp we're going to be using, like I said, is the OP27, and the pinout for it is the following. So we have voltage input, we have voltage negative right here for 4, and then pin 7 is voltage positive. Those are going to be what power our op-amp. We have the negative input and the positive input, and those are the negative and positive inputs for our op-amp, the back of it, and then the 6 is our output. So I'll have this up, which I will be looking at. I should also have it posted when I do each of the circuits. So this is the op-amp we are going to be using.